if time travel were possible, it would raise many questions and possibilities. One question that often comes up is, where are all the visitors from the future? If time travel were possible, it's likely that people from the future would visit the past at some point. Time travel is a popular concept worldwide, thanks to science fiction. Although we often explore the concept of time travel through entertainment media such as TV shows, movies, and books, the majority of people believe that it is impossible to travel through time due to either biological or philosophical reasons. According to Albert Einstein, he said, "People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion." Let me explain the time paradox in a few words. The time paradox is a concept that refers to the idea that our perception of time is not a linear progression from the past, through the present, and into the future. Instead, the way we experience time is shaped by our individual and collective memories, expectations, and beliefs about the past, present, and future. This can lead to paradoxes and contradictions, as our understanding of time is influenced by how we perceive events and experiences in relation to one another. Since time travel is a contradiction itself, paradoxes were generated. These paradoxes fall into two types: consistency paradoxes and causal loop paradoxes. Let's begin with the consistency paradoxes and give a few examples. These paradoxes occur when a time traveler does something that did not happen in the past, creating a contradiction. The outcomes of these paradoxes cannot be predicted. A few examples are the grandfather paradox, Hitler's murder paradox, and Polchinski's paradox. The grandfather paradox is a really interesting paradox, as well as one of the most popular time travel paradoxes. The incident explained in this paradox becomes a paradox due to the inconsistency that occurs due to the change in history. It says, "What would happen if you traveled to the past before the birth of any of your parents, and killed your own grandfather? This decision will end the existence of the entire family line after your grandfather, and logically all of them, including you, should disappear." This paradox is not exclusively about killing the grandfather, it leads to a much broader question about the existence of time travel, like, if you are not even born, who killed your grandfather? Hitler's murder paradox is similar to the grandfather paradox. This time you go back in time and murder Adolf Hitler before he becomes powerful. Similar to grandfather's paradox, where you erased the very reason for your birth, now you have erased the very reason you came back in time. In addition, killing your grandfather has a limited butterfly effect, but killing Hitler? You stop World War II and the Holocaust. And also, you stop substantial technological advancements that came along with World War II, which might have paved the path for your time machine technology. Now, if Hitler doesn't exist, why would you travel back in the first place to kill him? And the last example, Polchinski's paradox. The paradox was found by American theoretical physicist Joseph Polchinski through a letter written to fellow physicist Kip Thorne. This time paradox is more scientific since it agrees with Einstein's theory. It states that if you send a billiard ball into the past via a wormhole at an angle, it continues along and exists in the past at the exact moment you send it in to collide with itself. Does that mean it didn't enter the wormhole in the first place? In case you don't know what a wormhole is. In theoretical physics, a wormhole is a hypothetical passage through space-time that would allow matter or information to travel from one point in the universe to another point in the universe, potentially even allowing travel through time. Wormholes are also known as Einstein-Rosen bridges, after the physicists Albert Einstein and Nathan Rosen, who first proposed their existence in 1935. As an answer to this paradox, the possibilities of collisions were examined by a team and identified many scenarios where the future ball hits or passes without hitting the future ball. After evaluating these scenarios with the help of quantum mechanics, the team identified the probability of ending up with an outcome that is non-paradoxical is very high. These are the three examples of consistency paradoxes. Now, let's look at causal loop paradoxes. What if a past event causes a future event, and the future event itself is a result of that exact same past event? These paradoxes are originless paradoxes, in other words, causal loops with a contradiction. Examples of these paradoxes are predestination paradox and bootstraps paradox. The predestination paradox is a situation in which a person traveling back in time with the intention to change the outcome becomes part of past events. Also, he is more likely to have a chance to cause the initial events which inspired the person to travel back in time in the first place. It is named the predestination paradox because history is meant to be predestined in this case. No matter if anyone tries to alter the past event, the event will end up being fulfilled. For example, let's say your cat gets hit by a car near a turn, and you decide to go back in time and fix it. Since you know the exact time and the place your cat dies, you are ready at the location to save the cat. Now your cat sees you from the other side of the road and starts towards you. Since you already know what will happen, you start running to stop the cat. Unfortunately, a fast car takes the turn and comes towards you at this moment. To not run over you, the driver turns the steering wheel and accidentally runs over your cat, killing your cat in the same way. You suddenly realize you are the very reason for the death of your cat. And now, the question to ask is, how did it all begin? Where is the actual origin? It's all a loop in time. For the bootstraps paradox. Instead of two events, in the bootstrap paradox, an object with specific information is sent back in time, making the endless loop. One day you get a book delivered to your house about building a time-traveling machine. You start building the machine and after 20 years you complete building the machine. Then you go back in time and deliver the book to your past self. Now, who initially wrote the book? Most of these paradoxes are very confusing, but let's look at some of the answers to these paradoxes. As an answer to these paradoxes, there are two hypotheses generated. As with the concept of time travel itself, these hypotheses are more connected to fiction than science. We have the timeline protection hypothesis and the multiverse hypothesis. There's a third solution called the Novikov self-consistency principle, which provides a more scientific answer, especially to the causal loop paradoxes. For the timeline protection hypothesis, according to the timeline protection hypothesis, the universe has a built-in mechanism that prevents time travelers from altering the past in a way that would create paradoxes or otherwise disrupt the continuity of the timeline. This mechanism could be physical, such as some sort of barrier or force field that prevents time travelers from interacting with the past, or it could be more abstract, such as a set of metaphysical laws that govern the flow of time. There is no scientific evidence to support the existence of a timeline protection hypothesis, and it remains purely speculative. However, the idea has been explored in various science fiction stories and has been used as a way to resolve paradoxes and other inconsistencies that might arise in the context of time travel. The solution explained under Polchinski's paradox also falls into this section, but more with a scientific base. Obviously, previous solutions sound fictional. Logically, you shouldn't be able to do anything in the past according to this theory. In other words, you are a ghost from the future that only can observe what happens. The chronology protection hypothesis by Stephen Hawking is a scientific version of this hypothesis that states appearance of closed time-like curves is not allowed by physics. And for the multiverse hypothesis. Each universe in the multiverse exists in its own separate timeline, and these timelines may be connected by various means, such as through the use of wormholes or other hypothetical constructs. If this is the case, then it is possible that time travelers could move between different universes and different timelines, potentially allowing them to visit the past or future of their own universe or of another universe. The multiverse hypothesis is a highly speculative theory that is not supported by mainstream scientific evidence. However, it has been proposed as a way to resolve certain paradoxes and inconsistencies that might arise in the context of time travel. For example, if a time traveler were to visit the past and make changes that altered the course of history, the changes might only affect the timeline of the universe that the time traveler visited, leaving the timeline of the time traveler's own universe unchanged. This could potentially allow for time travel without creating paradoxes or other inconsistencies. And then, Novikov's self-consistency principle developed by Russian physicist Igor Dmitrievich Novikov. This principle states that if an event causes a paradox or changes, anything in history has zero probability of happening, making it impossible to create a time paradox. According to the Novikov self-consistency principle, the laws of physics will always act to prevent paradoxes from occurring when time travel is involved. This means that if a time traveler were to visit the past and make changes that altered the course of history, the changes would have to be self-consistent, meaning that they would not contradict or disrupt the events that have already happened in the past. This principle is also confirmed by the previously mentioned evaluation results based on Polchinski's paradox. Time is often referred to as the fourth dimension, along with the three dimensions of space, length, width, and height. Time is also the only dimension that has one direction. It only can move forward, not backward. This way of thinking about time can be helpful in understanding some concepts in physics and mathematics. Many dreamers have wondered what it would be like to be able to travel backward through time, but based on our current understanding of the laws of physics, such a journey is only possible in dreams and our wildest fiction. In physics, space and time are often considered to be part of a single entity known as space-time. Space-time is a mathematical model that combines the three dimensions of space with the dimension of time, and it is used to describe the behavior of objects and events in the universe. According to the theory of relativity, the laws of physics are the same for all observers, regardless of their relative motion, and this principle is often expressed in the form of the space-time interval. Overall, the concept of the fourth dimension is a useful way of thinking about the relationship between space and time and how they interact in the universe. It is an important concept in both physics and mathematics, and it has helped scientists and philosophers to better understand the nature of the universe and the fundamental laws that govern it. Years back, no one had thought that we can talk to a person 3,000 of miles away with just a box in our hand, but today the smartphone is normal. It's no surprise that Hawking once believed time travel to be impossible. There are simply too many paradoxes involved in the whole procedure. Similarly, implementation of this theory in practice may seem impossible at present, but this does not mean it is impossible. Our current understanding of the universe is limited. There's still a lot to explore about nature. Moreover, all of the existing candidates for the theory of everything are insubstantial to answer this. Though time travel is impossible as of now, it's fun and fascinating to imagine. However, there are a few possible explanations for why we may not have seen any visitors in the future yet. One possibility is that time travel is simply not possible, and all the theories about it are speculation. Alternatively, it could be that time travel is only possible under certain conditions, and we simply haven't met those conditions yet. Another possibility is that time travel is possible, but it comes with certain limitations or risks. For example, it could be that the technology required to travel through time is not yet available to us, or that the consequences of altering the past are too great to justify the effort. Finally, it's also possible that visitors from the future have already visited us, but we simply don't realize it. If time travelers were able to blend in with our society and go unnoticed, we may never know they were here. Ultimately, the question of where all the visitors from the future are is a tantalizing one, and it's likely that we won't have a definite answer until time travel becomes a reality. Adding to the paradox, there's another famous one called the Fermi paradox, describing why aliens have not visited the Earth. If you want to know more, click the video up on your screen. Thanks for watching today's video and subscribe for future videos.